All right, we're going to work on exercise one on the surface area and volume of pyramids notes. And exercise one is a lot of just the vocab associated with the pyramid. So we're going to draw a right square pyramid. Okay, when I draw a square pyramid or even like a rectangular pyramid, I try to picture it like where one of the corners of the base is facing towards my direction. So I'll start it by like drawing like that corner facing me. Okay, so then I could put a vertex up here. I have one lateral edge there, a second lateral edge that kind of completes like one of the isosceles triangles, which would be one of the faces. I have another one here, okay? And then I also understand that there's more to this shape in the back. I'll kind of like draw some dotted segments in there. So I have a vertex. I know that there's a square base. These are considered the base edges, which are congruent. These are the lateral edges, where if it's a right square pyramid, the lateral edges would be congruent. So the vertex is the point where the lateral faces meet, and the lateral faces are in this case, the four isosceles triangles. Okay. The base, it could be any polygon. In this case, it's our square, and the lateral face. The lateral face are the triangles, the triangles that meet at a vertex. And if it's a right regular square pyramid here, then those lateral faces are going to be isosceles triangles. Okay, so a base edge. A base edge are the edges that connect the base to a lateral face. So the base is a square, the lateral face is a triangle, so the base edge is the side that connects the base to the lateral faces. So in this case, it would be kind of outlined in red. Those are our base edges. Since it's a square, the four base edges are congruent to each other. Okay. The lateral edge are the edges that connect any two lateral faces. So it also connects any of the vertices of the base to the vertex. So vertice of the base to the vertex. So there's the lateral edge. So we have four lateral edges. If it's a right pyramid, that means that the vertex would be directly above the center of the base. So your lateral edges would be isosceles triangles. So kind of mark that. Okay. The height is the altitude. It's the shortest distance, or the perpendicular distance, from the vertex to the base. So in this case, if we had this particular example, let's call that the center of the square pyramid. The height would go from the vertex to the center of the base, and it would be a perpendicular distance. So it would be the shortest distance, or perpendicular to the base. So I'm going to kind of tighten there. So I'm going to put an arrow and identify our height. Okay, and then the last thing to identify in the diagram is the slant height. The slant height is the height of the lateral face. So the lateral faces are triangles, so it's the height of the triangular faces. So it is the distance from the vertex to the base edge. So in blue, we have the slant height. I'm going to use lowercase l in the diagram for slant height. So it's got to go from the vertex along the lateral face, along the triangle, and perpendicular to the base. So if the base is a regular polygon, it would cut the base in half. Right, so there we go. We'd have the slant height as well. Okay, the last thing I'd want to mark on here the last thing I'd want to show or consider is some old vocab from the previous unit should come into play, and that would be like the fact that if I connect the height to the slant height, if it's a regular polygon, the apothem would connect the altitude to the slant height, and you would get a right triangle there. Okay, the radius would, if it's a regular polygon, the radius would connect the altitude to the lateral edge, right? And then that would give you a different right triangle. So I'm going to make a note here. If we had a regular, if the base was a regular polygon, the base is a regular polygon, then we can get a right triangle that would be formed by the altitude. I'm going to use purple again for the altitude. The altitude, the slant height, the slant height would be the hypotenuse, so we could see that here, the altitude, the slant height, and we connect that with the apothem of the regular polygon, we'd have a right triangle. Okay, we'd also get a right triangle if we connected the altitude and we had the hypotenuse, which was a lateral edge, and then I'm searching for another color here. I'll use a pencil. So the altitude, the lateral edge, and the radius of the regular polygon would form a different right triangle. And that's all has to do with the fact that the altitude has to be perpendicular to the base. All right, there's exercise 1.